In this video, we'll be looking at section 6.3. ASA and AAS triangle congruence. And our essential question is, how do I use ASA and AAS to prove two triangles are congruent? So we're going to add in our last two theorems that help us prove that triangles are congruent. We have side, side, side. We have side, angle, side. Now we'll add these two, angle, side, angle, and angle, angle, side. So I won't need to talk about this idea too much because we've already discussed how this works, so we can just really dive right in. So the first one we'll do is angle, side, angle. Which will be our ASA. And the way this one will look is we'll have two pairs of congruent angles and the side connecting those angles. So let's draw a couple triangles. So if I have this angle, it's congruent to that angle. Let me get some letters going. So if I have angle GDF is congruent to angle LKM, angle GDF, that's this angle right here, is congruent to angle LKM. And then we'll say that these angles are congruent. So I can say angle GFD is congruent to angle, so if I went GFD, I'm going to go LMK. And then now, so we have our two pairs of congruent angles. Now the side is the side in between the two angles, connecting the two angles. So it has to be this side right here, this bottom side of the triangle. So here's our tick marks to show that congruency. And we'll say DF is congruent to KM. So there's my angle, side, angle. So, like a sentence we could say to explain this is, because we are given that angle GDF is congruent to angle LKM, side DF is congruent to side KM, and angle GFD is congruent to angle LMK. Because we are given that angle GDF is congruent to angle LKM, DF is congruent to KM, and angle GFD is congruent to LMK, we can say triangle DGF is congruent to triangle KLM by angle, side, angle. Because we have the angle, the side, and the angle, so we can say the two triangles are congruent. So now we'll do the same idea, but instead this time we'll look at angle, angle, side. So we're just going to jump straight into the picture. Like that. R, S, T, A, C. Okay, so let's look at our given information. And this is angle, angle, side. So given, that means this is how the problem's looking. We're given this information. We'll be given that angle RST is congruent to angle CAB. And then we'll be given that angle STR is congruent to angle ABC. And now we just need a side that is not in between. So we're looking for, if we're given any other side, except for the one that's in between the angles, so if we're given SR and AC, then we can use that, or if we're given RT and BC, both of those would work. So we'll just look at this one, because now I have angle, angle, side. But I also could have gone angle, angle, side, so both would have worked. And we'll say SR is congruent to BC. So again, I cannot stress this enough. We can go angle, angle, side, and we could have said TR is congruent to BC, but instead we were given that it's angle, angle, side, and so we have the left-hand side as our third piece. Now we can make our statement. Because we are given that angle RST is congruent to angle CAB, angle STR is congruent to angle ABC, and side SR is congruent to the side BC, we can say that triangle STR is congruent to triangle ABC by angle, angle, side. And that's how you can use the angle, side, angle, and angle, angle, side theorems to show and prove triangle congruency. So thank you very much for watching this video, and I hope you have a great rest of your day.